Welcome everyone. It is 3 p.m. and it's time for a server room show. This is episode 45. I'm sorry if suddenly I sound very loud because I changed some assignment around the microphone and now it's on a different stand than before, but it won't last long as a microphone boom arm is coming hopefully before the episode of next Saturday, and it will hold everything in place nicely finally. So today I would like to talk about Rancher and Heimdall application dashboard. If you remember, in episode 18 and 19 of the server room show, we have already discussed Docker and Kubernetes in detail, and even before or around those episodes we have also discussed microservices. If you don't remember, then I recommend that you go and listen to those 2 episodes at least, and ideally also to the microservices episode, because that would give you a foundation and an understanding to be familiar with what the heck is Docker and Kubernetes, and why they exist in the space of IT, what their use cases and what they're good for, why we are just not practically running everything on a single server or running everything in virtual machines. But if you don't remember, and if you not going to go back and listen to those episodes, in very short I can say that Kubernetes is a platform for automating deployment, scaling and operations of application containers across clusters of hosts, and it works with a range of container tools, and one of those are including Docker. So that already tells you that Docker is an engine to work with containers. So Rancher is just one of the platforms for Kubernetes management, for enterprise Kubernetes management platform. It's a complete container management platform. Rancher is a complete software stack for teams adopting containers. It addresses the operational and security challenges of managing multiple Kubernetes clusters while providing DevOps teams with integrated tools for running containerized workloads. Rancher is open source software, and from data center to cloud to edge, it lets you run Kubernetes everywhere. However, Rancher is not the only Kubernetes management platform out there. The other 2 most notable, at least one of them, is Red Hat's OpenShift and VMware's Tanzu, which honestly I have not heard about just before I was preparing this episode. So why you would need something like Rancher? Because if you thinking about working with Kubernetes orchestration platform to take advantage of Docker and Docker containers, for example, as one of the supported underlying engines for Kubernetes is Docker. Then as long as you only have a single container, let's say, then life is good and everyone is happy. But the moment when you have n+1 of pretty much anything, it can be containers, clusters in form of Kubernetes clusters, or you can even say virtual machines or servers or switches or whatever to manage, you will eventually face with the same problems, the problems which in this case Rancher is trying to solve, similar to OpenShift and VMware's Tanzu. And based on Rancher's tale of the story, they are in a couple of aspects are solving these problems better than OpenShift and Red Hat's OpenShift and VMware's Tanzu. You can find those comparison PDF documents on Rancher's website, and based on Rancher, they sort out these problems better than the other two, because the main problem with a vanilla Kubernetes installation is the lack of central visibility. The security practices applied are most of the time inconsistent between various Kubernetes clusters, and to be honest, to manually manage one or even more than one Kubernetes cluster can be a complex process, and you have to remind yourself if you've done something, if you have set exactly the same way throughout the infrastructure or the platform, if the same settings have been applied on all the clusters or all the containers where it had to be applied, not even mentioning other aspects like the scalability. For example, Kubernetes can give you these kind of headaches and complex challenges are meant to be solved by these kind of enterprise orchestration platforms like Rancher, and Kubernetes was to solve or is to solve the similar approach or problems when you work with, for example, in the case of Docker containers, when you just simply work with Docker on your own. The moment you try to handle more than one container, then you need to have something to manage it efficiently and with a proper visibility and the mentioned security practices to be able to apply easily without the need to do everything manually and one by one. Kubernetes was already helping with this one, and Rancher just actually makes it easy to run Kubernetes on top of Docker. You will see in a second why. Kubernetes management platforms try to solve these issues we just mentioned: the security policy, the user management, all those shared tools and services, preferably with a high level of reliability, with easy and consistent access to these shared tools and services. High availability, load balancing, centralized audit, or integration, for example, with popular CI/CD solutions are just a few, for example, for DevOps to mention, which in question to be helped with or solved. Rancher has a thriving community on Slack, rancher.io, and forums on rancher.com. If you need help to get going with it. If some of the below questions ever popped into your head regarding operational challenges when designing your company's Docker or Kubernetes infrastructure, then probably Rancher could be a great fit for you if any of these questions sound familiar to you. How do I deploy consistently across different infrastructures? How do I manage and implement access control across multiple clusters and namespaces? How do I integrate with already in place central or the authentication systems like LDAP, Active Directory, or Radius? What can I do for monitoring my Kubernetes clusters? How do I ensure that security policies are the same and enforced across cluster or namespaces? Rancher was originally built to work with multiple orchestrators, and it even included its own orchestrator called Kettle. But with the rise of Kubernetes in the marketplace, Rancher, starting from the version 2.x, exclusively deploys and manages Kubernetes clusters running anywhere or on any provider. Rancher can provision Kubernetes from a hosted provider, provision compute nodes, and then install Kubernetes onto them, or import existing Kubernetes clusters running anywhere. One Rancher server installation can manage thousands of Kubernetes clusters and thousands of nodes from the same user interface. Rancher adds significant value on top of Kubernetes, first by centralizing authentication and role-based access control for all of the clusters, giving global admins the ability to control cluster access from one location. It then enables detailed monitoring and alerting for cluster and their resources, ships logs to external providers, and integrates directly with Helm via the application catalog. If you have an external CI/CD system in a DevOps setting, then you can plug it into Rancher, but if you don't, Rancher even includes a pipeline engine to help you automatically deploy and upgrade workloads. Rancher is a complete container management platform for Kubernetes, giving you the tools to successfully run Kubernetes anywhere. Another interesting thing to mention is that while for a standalone Kubernetes installation, you would need to fulfill more dependencies than for a Rancher plus Kubernetes deploy scenario. What I mean with that, the reason being behind that, Rancher itself, so if you want to deploy Rancher enterprise Kubernetes orchestration platform on your machine right now, then the only requirement is that the host to have a supported Docker version installed on it. It means that as long as, let's say, your CentOS server has a supported Docker version installed on it, there is a support matrix on Rancher's website, the operating systems and Docker versions and kernels and whatnot. You make sure that you have Docker installed, and then you can install, you can pull Rancher on it with one line of command, and then Rancher will deploy itself on top of this Docker engine on the host, and build out. When you click deploy cluster, you can build out a Kubernetes cluster running on top of Rancher, which runs on top of Docker on this host. On the other hand, if you wanted to do a vanilla Kubernetes installation on the host, then that would call for more dependencies than just simply having Docker on this host as a prerequisite. And yeah, this is achieved by Rancher, as I said, that it runs entirely inside, or so to say, on top of Docker, and Rancher then lets you run Kubernetes clusters on top of it, on top of Rancher. You can be up and running quicker this way than going through vanilla Kubernetes installation. For sandboxing environment and to test Rancher out, as I said, you can deploy it on a single host with a simple one-liner of command, as long as the host has Docker on it. But for production, you can go through their installation guide on the website. A minimum of 3 node cluster is required or recommended for those high availability and those kind of scenarios. So how to start with Rancher? Rancher has a great quick start guide to have you up and running in the lowest time possible. I left links in the show notes. You can try it out in a sandbox environment. Just grab any host, as long as it has a supported Docker version installed, like CentOS, and then you use the one-liner code to pull Rancher up inside Docker image to test it out and play around with it. You can run the code you find in the show notes. It's one line of code which runs pulls rancher and exposes its port to port 80 and 443. When this one is successfully finished, the result of this will be that rancher is deployed on the host's Docker engine, and it is running, exposing port 80 and 443, as I said. You pull up your browser and you go to https :/ to your server's IP or fully qualified domain name. On first logon, the default admin account will ask you to specify a password, and then it asks you to confirm the rancher server URL, which can be again an IP or a fully qualified domain name. Then the next step would be to create a cluster. When you log into rancher, the one who looking at my screen can see the screenshots. When eventually you log in, there are no clusters defined. You just click add cluster on the top right corner, and like that, to try it out, you can create as per this example using the custom option. You can add a cluster. You can just give it a name. You leave the member roles and cluster options for now, you leave it empty. You click on next, and on the next screen all you need to do is to make sure that the node options, specifically the node roles, all etcd, control plane and worker all of them are marked with a checkbox. You will see that when you mark and unmark these boxes, the underlying code you will need to copy and run on the underlying host where rancher is running on top of the Docker engine of the underlying host. The command slightly changes, so make sure all three of those you have marked, checked, and then you copy the code. You access the host of where rancher is running on top of Docker engine, let's say the server or the host machine. You access it via, let's say, SSH, and from terminal you run this command you copied, and that eventually starts the deployment of your Kubernetes cluster. You can click on done, and then you are back to the main screen, where now under clusters you will see that your whatever name you selected for your cluster is there in a provisioning state, and under the provisioning icon you can see the actual step it is taking, or if there is any error, you can see more or less what the error message is. Not completely, but at least it can give you some indication of what's going on. If you were to look at a sudo docker ps command on the host machine while you are deploying the Kubernetes cluster with rancher, you would see that depending on the moment when you are doing this check, you either see more or less different containers exist on your host machine at a given time. But eventually, when everything settles down and everything is done, then I think around like 9 or 10 or something like that, how many pods are, because in Kubernetes the smallest unit is a pod, so around 9 pods were 9 or 10 pods were created. I have a screenshot. I have a few screenshots in the show notes about all the containers on top of the Docker engine Rancher was creating when it was building up the Kubernetes cluster. I don't know if I will leave it in the show notes or not, because in the very beginning, when I was preparing this episode, I did run in an issue about certificate, batch certificate, this and that, based on the checking the etcd Docker containers log file, and I spent some time trying to fix this error, but then I ended up looking at the support matrix. That's why I know that it exists, and it's there on Rancher's website. And I saw that Fedora 32 and its kernel version was definitely not on the systems where it expected to work perfectly or out of the box. Definitely not supported. So I would say that I think I will leave this error I had, or the way I ended up having this error. I leave this in the show notes, but I will mark it somehow that it most probably was because of the combination of kernel and my distribution of choice. The funny is that eventually, when I did try it on the latest kernel 5.8 on Fedora 32, it was working. But then on kernel 5.7, when I booted back to 5.7, because I'm not using 5.8 because it broke VMware and VirtualBox for the moment, on 5.7 it was not working. So it could have been a mix and match of the kernel, the distribution I'm using, perhaps even the Docker engine version. However, that 1903 indeed is supported. But nevertheless, what I did, that I picked up a supported distribution in a virtual machine, CentOS, and I managed to have it up and running there, just as I managed to luckily run it in Fedora 32 but under kernel 5.7 for some reason. And I managed to create the Kubernetes cluster, so I could continue the article. Once the Kubernetes cluster created, you can access its dashboard, and it shows CPU memory and pods usage. Pods being the smallest units in Kubernetes, and yeah, as I said, it worked on CentOS 8 as it's a supported system. Make sure you check. I also left it on the show notes, the Rancher support matrix, the systems supported. And after this, that I had the Kubernetes cluster up and running, I could then continue and go to the second piece of thing I wanted to talk today, is Heimdall application dashboard. It's still a bit fuzzy for me. What can I do with it? Because as per the website, Heimdall is what it says. It's a dashboard for all your web applications, and it doesn't even need to be limited to applications, though. You can add any links to anything you would like, and indeed it's an elegant solution, and it looks nice for this purpose. You can even add a search bar, so ideally you would set this Heimdall's page to be as your start page, and then you could have your search bar and all the other links or applications, web applications, which can be either generic or foundation enhanced apps, which can even show you some real-time information. You will see it in a second if you're looking at my screen. However, the thing is that when I was trying it out, I ended up not having any of those generic or foundation or enhanced applications already in my environment, so I couldn't pin it to this dashboard because I didn't have them already in my environment, like nzpget or 7zbd to show the downloads or how many things are pending, or other compatible web applications running in a Docker container, which ideally one of the best fits for this application dashboard of underlying web applications running in Docker containers, and with these pieces of called applications which you can grab from Heimdall's website. You can expose or pin them to the dashboard and have them show you specific information. On Heimdall's website there is a quite short video which shows you a tiny bit what's going on, so I'm sure that also can help you understand this better. The thing is that you can also add like I did generic web URLs, and then it stays pinned on the dashboard, but its real power is not from this. For example, if you use what Heimdall calls a foundation application, then you foundation enhanced applications, you can also do things with APIs and like I said, view live statistics and these bits and pieces of information as per that underlying application, for example running in a Docker container, supports, see them directly or interact with it directly through the dashboard. And there is a tons of application mentioned on Heimdall's website, and even you can even request more. So what I did, and you can also once you have the Kubernetes cluster up and running, you can just go and try out, for example with Heimdall on Rancher and on the Kubernetes cluster. You can try to deploy and play around with Heimdall. You go to on the main screen of Rancher, you just go to global, you select your Kubernetes cluster you created earlier, and you click on the default namespace. You then click on the deploy button on the top right corner, and then on the deploy workload tab you just specify a name. You can leave the workload type of scalable deployment of 1, and in the Docker image, which is a mandatory part to fill out there, what you have to put is the part you would put behind the Docker behind the normal Docker pull command. So in this case, if I want to deploy Heimdall in Docker, I would need to put Docker space pull space Linux server / Heimdall, and that the portion I had to put there, deploying to the default workspace namespace. And another important thing, the port mapping. I had to manually add a port which exposes port 80 of the container through TCP and as a host port, so it's a nodes running a pod to a given port on the host, underlying host, which runs Docker engine and Rancher, and on top of it Kubernetes cluster. I selected 8082. I clicked on launch, and it resulted that the IP, I took the IP of my underlying host, as you see on my screen if you the ones looking at it, and the IP colon the port I specified shows me the running Heimdall dashboard or website. And this is where you see, this is how far I got, that I was able to put 3 links or icons for the things I could, because I had no other underlying Docker images or web applications to use for this demonstration. We ran out of time. I wanted to say a few more things, but I guess I see you next Saturday.